Hi folks, welcome back to Math with Captain Rod. Making this video here to go over radical expressions here and how to simplify them. So first thing here, I'm going to take note in these notes where it says you may want to make a square root chart for quick reference. This is kind of what it's talking about here. I'm going to write some things down. We know that. Oh, get my pen on here. Sorry about this. All right, so 1 squared is 1 times 1, which is 1. 2 squared is 4, 3 squared is 9, 4 squared is 16. I'm just going to do 1 or 2 more. 5 squared is 25, right? So working it the other way, this radical and then a 1 means square root, and it means what value squared gives you 1. As we look here, 1 squared is 1. And then the square root of 4 we would say is 2. Square root of 9. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5, and so forth. All right, so this is what they're talking about table-wise to have this kind of handy. All right, so where it says simplify the radical expressions. So this one's pretty simple. Square root of 25 is 5 because 5 squared is 25. Now, negative 5 squared is also 25, but written in this form, you're looking for what's called the principal square root, the positive number squared that's equal to 5, so we don't include the minus sign in that calculation. All right. Moving on down, and what I'm going to do is I'm going to do the odds here, and I'm going to save the evens for exercises to the reader here, or the video watcher here. So we're going to take a look at this one, 72. Now, continuing on here, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81. You'll notice that 72 falls between 64 and 81. 72 is not a perfect square, so we're not going to get a nice integer deal here like the 5. But what we can do is we can break this down, and let's see, the 72. Let's see, we can write this. How about 9 times 8? And we can simplify that maybe a little bit further, maybe 9 times 4 times 2. And 9 is a perfect square. Square root is 3. So in effect, that can this can be calculated. 3 square root of 4 is 2. And then we're left with this just square root 2 under the radical. And then, of course, 3 times 2 is 6, so 6 root 2 is the square root of 72. You should be able to square this, you'll get that value back again. All right, let's take a look at this one. Number 5 here. Okay, 3 times the square root of 44. Well, 12 squared is equal to 144. So the square root of 144 is 12. So this is equal to 3 times 12, which is 36. Take a look at this guy, 88. Okay, 88 is not a perfect square, so what we're going to have to do is break this up a little bit. Let's see, how about 8 times 11? And then 8 can be written 4 times 2. Now, this, property of square roots and multiplication, the way this works, I don't think I wrote this out last time, but this can be broken up into square root of 4, square root of 2, square root of 11. And the square root of 4 is 2. So 2 root 11. Or, putting it kind of back together, maybe, how about 2 root 22? And that's about all we can do with that one. Moving on. Simplify variable radical expressions. So, all right, this square root of x to the 6th. There's lots of ways we can write it. Pardon me. Let's see. This x to the 6th can be broken down several different ways. I like to, when I first talk about this stuff, break them down like this. This can be written x squared times x squared times x squared. Notice that x, squared, squared, and squared, that's x to the 6th. And each one of these can be done individually if I actually write it out. And the square root of x squared is x, and the square root of that x squared also x, the square root of that x squared also x, so this is equal to x cubed. So you can write them individually like this. The other thing we could have done is we could have wrote the square root of x squared cubed. And then the square root of x squared is x, and there's 3 of them, right? So this would end up being x to the 3rd power. That would be perfectly fine as well. Right, moving on. All right, taking a look at this. Now we have numbers and variables here. So this 16, that can be square rooted right away. Let's do this. Square root of 16 is 4, and then square root x to the 7th, y to the 10th. All right, now what we'll do is we'll just kind of keep working on this, right? That 4 will stay out in front, and let's deal with this. Now that x to the 7th, there's a couple ways to write it. Let's write it like this: x squared times x squared times x squared, and one more times x. I know this is a lot of writing, but I think this really shows very well how this works. This y to the 10th, we can write that y squared times y squared times y squared times y squared times y squared. 2, 4, 6, 8, 10. Yep, there's 10 of them. All right, now anywhere we have a square, we can take the square root. So this is going to equal 4 times x. All right, square root of this x squared is x, and there's 1, 2, 3 of these, so we can basically bring out an x to the 3rd. This will stay under the radical. We can't square root that. Okay, this stuff right here, we're going to have a y to the 1st, 2nd, 3rd, 4th, 5th. And what's left under this radical is just that lonely x there. Not much more we can do with that. All right, moving on here. Let's take a look at this one. All right, this one has an x in front of it, and just leave it alone. There's really nothing to do with that. And the square root of x squared is x, and the square root of y to the 4th is y squared. So this ends up equaling just x squared, y squared. I know I promised the the evens for the anybody watching the video, but if you don't mind, I'm going to go ahead and take a look at this one as well. So this 36, this can be square rooted. I guess I'll just leave it alone for a moment. Square root of 36 is 6, no problem there. This a to the 6th can be written a squared times a squared times a squared. This b to the 9th can be written b squared times b squared times b squared times b squared. That's 2, 4, 6, 8, and one more. I know this method is a lot of writing, but I do like how it shows very nicely how these simplify. All right, so this is going to equal 4 times, right, square root of 36 is 6. Square root of a squared is a, and there's another one, and another one, so this will be a to the 3rd. Square root of b squared is b, and there's another one, so that's 2nd, 3rd, 4th, so that's b to the 4th, and this b right there will have to stay under the radical. We can't square root it. We can clean this up a little bit. Let's call this 24, a to the 3rd, b to the 4th, square root of b. Nothing to do there. Nothing else we can do with that. And I'm just going to kind of double check and make sure that we're good here. 6, a to the 3rd, yep. B to the 1, 2, 3, 4, yep, looks good. All right, moving on. All right, so this guy. Now, remember that when you square root something, I'll say square root of x squared here, you're talking about principal square root, which means it's a positive value. So if this is a 16, this would be a plus 4. Well, here, if I did square root of x squared is x, really in reality, we would be taking just the positive value of that. That's going to come into play right here when we take the square root of this x minus 3 squared. So when we work this, all right, square root of 49 is 7. And the square root of x minus 3 is x minus 3. But remember, we're actually taking what's called principal square root. And here, there are values of x, of course, that would make this negative. So what we're going to do is throw an absolute value on that to guarantee a positive number there. Moving on. Actually, okay, so we're getting into addition and subtraction, so I think what I'm going to do is end this video right here at 9 minutes and 50 seconds. So, point of this video here was to talk about how to handle square roots for radical expressions. I hope that this has given you a reasonable idea how to do so. Have a great day.